Part 1 Introduction. Hello, and welcome back to Astronomy in 10 minutes. Today, we are going to explore one of the most cataclysmic events in the universe, the collision between a neutron star and a black hole. This collision is a rare occurrence, but when it does happen, it unleashes an incredible amount of energy and has the power to reshape the fabric of the universe. Part 2 What is a neutron star? Before we dive into the collision between a neutron star and a black hole, let's first understand what a neutron star is. A neutron star is the collapsed core of a massive star that has gone supernova. When a star runs out of fuel, its core collapses under the force of gravity, and the resulting explosion can be seen from millions of light-years away. What's left behind is a dense, compact object made almost entirely of neutrons. Neutron stars are incredibly dense, with a mass similar to that of our Sun, but squeezed into a sphere with a diameter of only about 10 kilometers. They also have incredibly strong magnetic fields, which can be millions of times stronger than the Earth's magnetic field. Part 3 The power of a black hole. Black holes are the most powerful objects in the universe, with the ability to vote space and time around them. They form when a massive star collapses under its own weight, creating a singularity, a point of infinite density, surrounded by an event horizon, beyond which nothing can escape. Black holes come in different sizes, with the smallest ones being only a few times more massive than the Sun, while the largest ones can have masses equivalent to billions of suns. Their gravitational pull is so strong that even light cannot escape from them, making them invisible to telescopes. Part 4 The collision between a neutron star and a black hole. When a neutron star and a black hole collide, the result is an incredibly violent event that releases an enormous amount of energy. The black hole's gravity is so strong that it begins to tear the neutron star apart, pulling it into an accretion disk of hot gas and dust. As the material spirals towards the black hole, it heats up and emits intense radiation. Eventually, the neutron star is completely consumed by the black hole, and the resulting explosion releases more energy than the whole Milky Way. The collision creates ripples in spacetime known as gravitational waves, which were first detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. Part 5 The aftermath of the collision. The collision between a neutron star and a black hole is a rare event, and the aftermath can vary depending on the size and properties of the objects involved. In some cases, the collision can result in the formation of a new black hole, while in others, it can lead to the ejection of material at high speeds, creating a bright burst of radiation known as a gamma-ray burst. Gamma-ray bursts are the most energetic explosions in the universe and can be detected from billions of light-years away. They are thought to be caused by the same kind of collisions that produce gravitational waves. Part 6 Conclusion. Thank you for joining us on this journey into the collision between a neutron star and a black hole. This incredible event is a reminder of the power and beauty of the universe and the importance of exploring and understanding it. By studying these rare events, we can learn more about the nature of gravity, the structure of the universe, and the origins of the elements that make up our world. Don't forget to like and subscribe for more videos on astronomy.